Hello students, let's look at this problem on factorization. Factorize the expression and divide them as directed. So let's write this algebraic expression in the fraction format. So 12pqr times 6p square minus 13pq plus 6q square whole divided by 6pq times 2p minus 3q. So if you watch, these factors can be eliminated. So 6 2 times gives us 12. At the same time we can eliminate p and q and q. So we are left with 2r into 6p square minus 13pq plus 6q square by 2p minus 3q. So there is still room for factorization in the numerator but not the denominator. So we will leave the denominator as it is and factorize the numerator. So in the next step, let's try to split this middle term. So here we have 6p square and 6q square. Let's multiply the 6's. So 6 into 6 gives you 36. Now try to split 36 in such a way that on multiplying you should get 36 and adding you should get negative 13. So if you take negative 9 and multiply it by negative 4, you will get positive 36, and when you add negative 9 with negative 4, you should get negative 13. So we can use this factor negative 9 and negative 4 to split the middle term, that is negative 13pq. Let's split it. So 2r times 6p square minus 9pq minus 4pq plus 6q square whole divided by 2p minus 3q. Now if you watch here, we can take something common in these two terms as well as these two terms. Let's try to take the common thing out. So 2r, let's use a curly bracket. So we can take out 3p times 2, 3 2s are 6, and p for p square minus 3 3s are 9 and 1p we have already taken common, so we are left with q minus 4 and 6. So we can take 2 common and a q as common, and inside the bracket we can leave 2 2s are 4 and a p. And now you see there is a positive sign. We want a positive after opening the bracket, so we'll take a negative sign inside the bracket. So it will become 2 3s are 6 and 1q is already out, so 1q is left here. And let's close the entire thing with a curly bracket. The whole thing divided by 2p minus 3q. Now we can take this expression and this expression in the two terms as common. So let's write it down as 2r common to all, and inside 2p minus 3q, and what we are left with after taking this common, 3p minus 2q, and in the denominator we have 2p minus 3q. So we have the same factors in the numerator and denominator, so we can get rid of 2p minus 3q and 2p minus 3q, and we'll be left down with 2r into 3p minus 2q. Can we factorize it further? No. So it's completely factorized, and we have divided both the expressions as well. So this will be your answer. Thank you.